In a cuboidal box, 8 identical spherical balls are kept in 2 rows with 4 balls in each row. Above these 3 balls identical to the previous 8 balls are kept in the space between the balls such that each ball touches 4 balls below it. Now water is filled in the box up to the height equal to the radius of the sphere. What is the minimum distance between the sphere and the second layer and the water? This question requires a lot of imagination since it is based on 3D mensuration. First of all, let's try to understand what the situation is. Let me draw a top view of it, although it's not helpful in solving the question, but it will be helpful in imagining what exactly the scenario is. So let's say these are your 4 balls in 2 rows, and these are the balls in the second row kept above these 4 balls. Fine, this is the top view. Now look at the side view. In side view, what we will see, only one row of the lower layer and the other row will be behind this row and the second layer. Fine. Now we know that the water is filled up to this height. Fine. Let's say if this is our box, the water is filled up to this height. Fine. And these are the centers of the circle. Fine, I'll make this figure a bit bigger. What is this? This is a triangle formed by the center of the second layer and the two centers of the lower layer, where A is the center of the sphere in the second layer and B and C are the centers of the sphere in the lower layer. Now if we imagine, we see that it's not just B and C. There are 2 points again behind B and C, let's say D and E, which are the centers of the spheres of the second row in the first layer. Now this A, B, C, D, E is a pyramid. Fine. And in that pyramid we see that each side is equal to twice of the radius. This is 2r, this is 2r, this is 2r. Pyramid, and we know that BCDE is a square. So it's a square pyramid. If I say, I am just drawing that point B, C, D and E. And there is a point, this is, let's say, point A above it. Now if we see that the side of this square is 2r, side of square BCDE is 2r. Fine. So the diagonal of this square will be 2 root 2r, and the point which is, this is A, the point which is exactly below A in the same plane where the square BCDE lies, let's say the point is Q. Fine. So the distance BQ will be half of 2 root 2r, that is root 2r. Fine. So now we have to find out the length of AQ. Fine. We see that A, Q and B forms a right angle triangle. Triangle A, Q and B is a right angle triangle. With right angle at Q. So I can say that AB square is equal to BQ square plus AQ square. AB I know is 2r, BQ I know is root 2r. So I'll get my AQ square as 2r square, or AQ is equal to root 2r. Now I've got my AQ. I know that this AQ is the distance. AQ is what? AQ is the distance between water and the center of the sphere in the second layer, and center of sphere in second layer. I have to find out the minimum distance between the sphere in the second layer I have to find out the distance between minimum distance between the water and the sphere in the second layer. So I have to subtract basically this distance, which I am marking it here, this distance from the root 2 r. So my answer will be root 2 r minus r, that is root 2 minus 1 into r. Or in other words, one can try to understand that this distance is root 2 r complete, and this distance is r, so the remaining distance here, it will be root 2 r minus r.